Hi, welcome everyone. So, we were studying about Brownian dynamics, and in the last class, we studied about how this Brownian part from observing Brownian dynamics and its positions, we can calculate its mean square displacement, velocity correlations, and different correlations. Okay, and we got to know depending upon the observation's time scale, if we see the mean square displacement, it shows two different regimes. Let's say if the observation time scale is very much less than the velocity autocorrelation time, which is tau v, then we can get a ballistic regime where the MSD grows as t square, but which is very much negligibly small compared to the time scale that we measure at our laboratory, where the velocity autocorrelation time is about picosecond or 10 nanosecond, but we measure at laboratory around millisecond regime, right? So there, the time scale is about it's very much smaller, larger compared to the velocity autocorrelation time. So in that regime where t is very much greater than tau v or tv, there actually we do not get any kind of ballistic regime. There it grows linearly as 2dt for 1D Brownian dynamics. Okay, so given that, now we will start to study a certain system which is called uh, where there is only just stochastic path, which is called random walk. So random walk has a plethora of of applications, be it in some colloidal motion, be it in let's say for any kind of polymers, how they move in the solutions. So it has a larger applications, and also beyond physics you can see this random walk and their applications in computer science, in economics, in finance, and all the other stuff. But the main aim or main recipe to tackle all these problems is, if we get the statistical mechanism, or the if you get the statistical quantities from these dynamics, then we can get some ideas. So today we will start this interesting topics is called random walks. So let me share my screen. Sorry, got lost. So if I share my screen here, so basically what we are studying, so I will spend quite a few time regarding this random walk. So, today we will study the sorry random walks or random flights. Okay, so it has immense applications in the field of polymer science, colloidal systems, finance, sociology, computer science, so on and so forth. Okay, so now I will give the description of this problem. Okay, so the main thing is, let's say there is a particle. So let's say there is one particle and it has few displacements. Sorry, this particle undergoes a sequence of displacements namely, let's say R1, R2, Ri, so on and so forth, where the magnitude and directions is not fixed. Magnitude and direction of each displacement being independent of each other. Independent of each other. Okay, or you can say of all the preceding ones. This is also true. Now the only thing is we have to find the probability. So the probability that the displacement Ri lies between Ri and Ri plus dRi. So that is actually governed by some distribution, governed by a distribution function, let's say tau I Ri, which is, this is assigned a priori, means you are given this probability beforehand, assigned a priori. Okay, now so what is our main quantity that we want to question that we want to ask is the probability which is like WRTR, that after in such displacement, in such events, in displacements, what is the probability that the coordinates or the position of the particle lie in the interval r, which is a vector and given as x, y, z tuple and r plus dr. So if we know that, then we can calculate this. This should be a vector. We should calculate this. Now r is nothing but r should be sum of all those things. So sum of I is equal to 1 to n ri. Okay. So it's a position of the particle. This is a position of the particle after n steps. Okay. Now this is mm, and all these positions, these ri's are taken by from a distribution. So these all ri's are taken from the distribution tau I r. Okay, so that is the main recipe. So this is a generalized thing, but first it's good to start from a basic case. So if we talk about a basic case, 1D is the most basic system. So let's say simplest one dimensional problem. So this is the problem of random walk. Simplest 1D problem of random walk. So let's first understand the problem first, then we get into this. So here the particle suffers some displacements. Okay, so here a particle. So what is the problem first? Understand the problem. So this problem says a particle suffers displacements along a straight line. Along a straight line in the form of a series of steps of equal length. So here we will also putting extra condition that these steps are equal lengths. Okay. So and each step is taken either in the forward direction, either in the forward direction or in the backward direction. Now, if you think about such n steps, so backward directions, each with a probability. So since there are two possibilities, so each with probability, then it will be half, right? Probability half, because there is only one way to go from here. It can go only in this direction and this direction. So half and half. These are the probabilities. If you consider such n after such n steps, if you consider after such n steps, the particle can be, let's say this is the starting point. So let's say this is minus n, this is minus n plus 1, this is minus n plus 2. So like this the dot, there will be 0 and 1 2 here dot, then this is n minus 1, n minus 2. So the particle can be in any of these site, right, with some given probabilities. Okay, now we ask this following question, that what is the probability, find the probability, find the probability W m n. I will talk about this, what this term mean, that the particle arrives at point m. That means m can be any number between minus n to n, right? M after suffering n displacements. Okay, this is our problem. So now since our first condition was that the steps, the probability of taking steps in forward and backward, that does not depend on the preceding ones. So probability of taking forward and backward step does not depend on the preceding ones, preceding steps. So that recipe is done. Now if you think about all possible sequences of each steps, sequences means it can go this side first or it can go this side. So if you think about all the possibilities, so number of number of possible sequences will be 2 to the power n. Just like if you think about uh, doing a tossing a coin, so it can get head and tail. So let's say if you uh, uh, you know toss 2 times, then the possibility of getting the possibility result is h, head head, head tail, tail head, tail tail. So 2 to the power 2, that means 2 to the power n. So this is like a same kind of thing. Okay, so this is the number of possible sequences. So probability of any given sequences, now if you take a probability of any given sequence, probability of any given sequence of n steps, that will be 1 divided by 2 to the power n, or we can write is 1 half to the power n, right? Okay, so now if we think about the probability Wmn, so the probability that is Wmn, that is Wmn, so that is nothing but, if we take what are those consequences that will lead to the positions m after n steps. So here it will be, therefore this probability of this sequence times the number of distinct ways or sequences of steps. Just a minute, there is some network issue. So what we will do, we will calculate this, what are those number of sequences. Okay, so here we will do is that this is the probability of each sequence, for each sequence. Now if we calculate the number of distinct ways to calculate those sequences of distinct ways of steps which lead to the point or position point m after n steps, right? Let's say if you want to go here in positive, if m is equal to 2, then n minus, if you take n minus, if you take, so you have to take 2 steps. Let's say you take, let's say for 8, let's say n is equal to 8 and you have to get to 2. So let's say you go in this way, 5 steps, and then again you go back to 3 steps here, then you will be there at 2. Or let's say you go here 3 times right side and again 3 times left side and in the next two steps you go this side, so there will be also 2. So you can reach to 2 in different ways. So we need to get to know the what are those ways to lead to the point M. Okay. So now we will calculate that. It's an interesting calculation. So now in order to arrive at M among n steps, let's say M is positive then, so we need to take forward step, we need to take n plus M by 2, this is forward steps, and backward step needs to be n minus M by 2, this is backward steps. How can I write this? You can easily write this. So let's say you take forward step nf number of forward step and nb number of backward step. Now if you add this, remember, if you add this will be total number of steps, that will be n, and nf, let's say forward steps is like +1 and backward step is -1. So if you do this, nf1 plus nb into -1, then that should lead you to m. So there you can get nf minus nb is equal to m. So from here you can easily calculate what will be the value of nf and nb. So this is quite trivial. Okay. So now you get what are the number of forward steps and what are the number of backward steps. But this can be arranged, this nf number of backward state and nb number of forward states and nb number of backward steps, that can be arranged in different ways, right? So how many, or the number of ways, the number of ways to choose the above steps, that is nothing but, so what are the possibility, total possibility if you take n steps, that is n factorial, and from that you are choosing n plus m by 2 factorial. If you choose this n plus m by 2 forward steps, then automatically it will give you n minus m by 2 backward step. So this is nothing but, if you write this will be the number of ways. Now in combinatorics we know this is written as n c n plus m by 2. So this is in combinatorics, this is the binomial coefficients. Okay. So now if you get this thing, then you can easily calculate this Wmn. So the Wmn, the probability of choosing the getting at the position m is, if you write this will be n factorial divided by n plus m by 2 factorial divided by n minus m by 2 factorial into to the power n, which can be written as like this also, n plus m by 2 into half to the power n. Okay. Okay. So this distribution This is called Bernoullian distribution. So this is called Bernoullian distribution. So now we got this probability. Now from here we will calculate few quantities. So now we will calculate few quantities. First, the mean of this, the expectation or mean of n plus m by 2. So n plus m by 2, and second is the mean square displacement, mean square displacement or mean square here it is deviation, mean square deviation of n plus m by 2. So we will calculate that. For that we will take help of the probability 101. Okay. Okay. So so okay. So for that we will use general Bernoulli distribution. General Bernoulli distribution is W of x is n factorial x factorial n minus x factorial p to the power x into 1 minus p to the power x. So since probability it's a two-state process, so probability will be 1, where p is greater than 1 and x is a positive integer and x is a positive integer which is less or equal to n. So we will calculate for this general expression and then we will get to know this. Okay, so now this can also be written as ncx p to the power x q to the power 1 minus x, sorry, n minus x, this would be n minus x, just a minute, sorry, this would be n minus x, this would be n minus x. Okay, so now this is the Bernoulli coefficient, this is the binomial coefficient. Okay. Okay, so now now we will see how we can get the coefficient of this value. Okay, okay, so now this NCX is actually, if you see carefully from binomial distribution, Wx is the coefficient coefficient of u to the power x in the binomial expansion of pu plus q to the power n. So basically Wx becomes coefficient of u to the power x in pu plus q to the power n. Okay. Okay. Now, first thing first, if you add all this probability, that should make 1, right? So probability of w into x, if we add all for all values of x, this should give you 1. Okay. So that means if x is equal to 1 to n, that should give you x is equal to 1 to n coefficient of u to the power x in q plus qn should be 1. Okay. So now what is the mean squared mean of x? Now mean of x, that is defined as x average, that is nothing but if you take x is equal to 1 to small n x wx, this is the average, let's say this is 1. Similarly, mean square deviation, means square deviation, which is, let's say, delta squared, that is actually, if you take, sorry, first deviation is x from x average, and now if you take it square and then average, if you take the average, this is mean square average. So that actually become, if you take x square, this average, minus x squared, that actually becomes, if you write in the expression of, this will be n equal to 1 to x is equal to, sorry, x is equal to 1 to n x square wx minus x is equal to 1 to n x wx its whole square, which can also be written as this xav x square. Now we will calculate these expressions. So now let me use a different color. Now mean, calculating the mean. So x average or x, which is can be written as x, is x is equal to 1 to n x times, which will be, what was wx? Coefficient of e to the power x in pu plus q to the power n. So coefficient of u to the power x in pu plus q to the power x. Okay. Now that means if you product this thing, then what becomes is, this is n, this is n. Now if you expand it, then this becomes, whether we can write it or not, let me first, x is equal to 1 to n coefficient of u to the power x in ddu of pu plus q to the power n. Why is so? Because what will be the u to the power x term? U to the power x term, I am just try to explain you guys. So let's say in the u to the power x term, if you take this term, this will be ncx u to the power x p to the power x q to the power n minus x, right? Now if you take derivative of this, then it becomes x ncx u to the power x minus 1 p to the power x q to the power n minus x. So this differentiation is like this, like this. So now this is the coefficient of, this is this coefficient, and when there was not differentiation, the coefficient was, so before differentiation it was x into ncx into px into qn minus x. So this term was this, and after this will be the this term. So this is this and this is this. So you can see these two things are same. So now we can easily write that coefficient of u to the power x in d du of this. Okay, now you can easily write this one as you can easily write as, if you x is equal to 1 to n, if you sum it off, then this becomes d du of pu plus q to the power n into where u equal to 1. Now if you do that, then x average becomes, so let's say if you differentiate it with respect to ddu, so what first becomes n, and it becomes p u plus q to the power n, right, to the power n minus 1. Okay, and again it becomes, if you do the calculations for this part, so first we take this, then again this part into, so first taken this is z, if this is taken as z, then you need to take it as d of pu du, that makes it n p, and at u equal to 1, so p plus q into n minus 1. Right, so this can be thought of as z. So first del 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 z, so del 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 z is this one. Okay, so now you can get n p, because p plus q is 1, that we have written earlier, where p plus q is equal to 1. So that we got here. So this step is actually pretty easy if you do this. So let's say if you take this as z, this is z, so this step can be readily done. So let's say assume z is equal to pu plus q, this becomes del del u of z to the power n, so it becomes del z to the power n into dz to the power du, chain rule. That's why it becomes n into z to the power n minus 1 into du dz, dz du. So if then dz du is p, so it becomes n pu plus q n minus 1 into p, right? Okay, so this is the value. So we got, sorry, so we got this average value. So this is equation 2. Now we will calculate the delta, mean square displacement. So this mean is mean of x is np. Now MSD, mean square deviations. To calculate that, first we calculate the average of variance, the variance or the average of squared second moment. So for this will become n1 into x is equal to 1 to n into x square into coefficient of u to the power x in pu plus q to the power n, right, which can be written as easily x is equal to 1 to n coefficient of, so first derivative gives this. Now we need to restore px, p to the power x, q to the power n minus x. Now if you further differentiate it, then it will give you x to the power minus 1, but we need to get x to the power, we need to get this one more x, so we need to multiply with again with u. So coefficient of u to the power x in ddu of u times ddu pu plus q to the power n, right? Because let's say if you do, so what was pu ddu of pu plus q? So this coefficient was, let me write here, this coefficient was, what was this coefficient of this term was ncx x square p to the power x q to the power n minus ox. So when you differentiate with respect to u, first becomes this, and if you then multiply with this, if you multiply u with this, then it becomes u again, 1x comes out and it becomes u to the power x minus 1 x square, and then you have to differentiate again to get it the whole thing, right? So like if you write this, then u du dx, that makes the coefficient of this, it becomes, you need to product this, so x ncx u to the power x p to the power x q to the power n minus x, and d du of u dx, that makes x square ncx p to the power x q to the power n minus x q to the power x minus 1. So this term is similar to this term, right? So in that way this is correct. Okay, now to solve this again, then this becomes coefficient of this x plus 1 to the power n. So if you add this, then this becomes d du of u d du pu plus q to the power n given that u equals to 1. U equals to 1. Now if you substitute this value here, then it becomes then it becomes d du u du something like this. So this becomes so if you differentiate for the first term, it will be u times n p plus q into the power minus 1. So first du is n pu plus q n minus 1 into p into p. So first you have to you have to do the operation, and at last you need to put equal to 1. Again this u n p, they all goes out, so it becomes then np d du of u into pu plus q to the power n minus 1 u equal to 1. So if you keep this one, then it becomes np for the first term d du is 1, so it becomes pu plus q n to the power minus 1 u equals to 1, and plus in p, if you keep u there, then it becomes u into n minus 1 into p pu plus q n minus 2 where u equal to 1. Now if you substitute u equal to 1 here, then it becomes np p plus q to the power n minus 1, and here np 1 sorry n minus 1 into p n minus 1 into p into p plus q to the power n minus 2, and this is 1, this is also 1, so it becomes np plus n into n minus 1 p square. Okay, so from here you can write that average of x square, that is np plus n into n minus 1 into p square, this is 3. Now m is mean square deviation, m is d, which is delta squared, that is x square minus x whole square. So this is np plus n into n minus 1 p squared, and in this is x square np, this is np, mean of is np, so this will be minus np time whole square. So that becomes np plus n square p square minus np square minus n square p square. So this cancels out and it becomes np 1 minus p, and that becomes npq. Why? Because p plus q is equal to 1, because p plus q equal to 1, so because q then will be q equal to 1 minus p. So from here we can easily see that mean square deviation, so mean square deviation delta square was npq. Okay, so now we will go back to this calculation again. So you will get, we will now get this calculation again. Okay, okay. Now if we go back to this calculation, then so n is the total number of observations. So now here what is x? That was wxn. So average was now similarly if we apply previously obtained result into the following things, then we will get first is the average of n plus m by 2, since the constant will get out, so this will be average of n plus m. Okay, now this n plus m, that average will be then what will be this average? It will be then np, so n by 2. Okay. Okay, so now again next thing is average of, sorry, the mean square displacement, which is n plus m by 2 minus n by 2, because this is the average, right, n by 2 whole square. So it becomes then n by 4. Okay, so n by 4. So you can get the idea, because this is the average of x. So this is equivalent to taking average of x. Now if this was np, this was np, so n was here, this was np, or here n was capital N and p was half, and this delta squared there was npq, delta squared was npq, and that was actually npq. So n is n, p is half, q is half, so n by 4. That's why you can easily see here. So here x is actually this one, this fellow, n plus m by 2. Now from here you can easily write, now here, so what we did was w xn was sort of w n plus m by 2 into n, right, because I took this as positive. At least there are some positive. Now from here n is, since this is equations 3, this is 4, this is 5, this is 6. So from equation 5 we can see that half of n plus m is n by 2, and this guy is a constant, so you can take it out. So n by 2 plus average of m by 2 is n by 2. This cancels out, and it makes average of m is equal to 0. So m average is 0. Now think about this, n plus m by 2 minus n by 2 whole square, and then its average. So then this is n square, n by 4, this is n by 4, and this n by 2 cancels out, and this becomes m by 2 whole square is equal to n by 4. That makes m square average by 4 is equal to n by 4, which makes m square average as n. So from here you can get this. So then delta m squared, that will be m squared minus small m squared, that makes it n minus 0. So delta m will be root n. So the mean square deviation actually is a square root of n. So root mean squared, root mean square displacement is root n. Okay, so there are few interesting points that what we have done here is that, so basically this, if you think about 1D random walk problem, there the root mean squared displacement or deviation is root over of n or root over of number of steps. Okay. Okay, so now we will return back to the original things, that what is the probability of WMN? What is the probability of WMN? Okay. Okay. So now we want to calculate, our main was our main goal, our main goal was to calculate the probability WMN. The probability WMN. So now we will calculate this. Okay. Now for our greatest interest arises when n becomes very large such that m is very less than n. Then we can, what we can do, that physicists are good at, we can simplify the whole thing. So we can then simplify our formula for WMN by using Stirling's formula. What is this? What was that? That log of in factorial can be written as n plus half log n minus n plus half log 2 pi plus the on the order of n minus 1. So where n tends to infinity, this is negligible. So for accordingly then we can write accordingly. We can write then we can write when n tends to infinity and m is very very less than n, then we have log Wmn n plus half log n. Of course, why? Because again I just want to write this Wmn is n factorial divided by n plus m by 2 factorial into n minus m by 2 factorial, then half to the power n into half to the power n. So for n factorial, log first it will be n plus half log n, because this minus n plus so there is 3. So this term we will write later. So this is log of this, so this will be half log 2 pi. Since n plus m in factorial is in the denominator, so that will be minus. So that will be minus n plus m n plus m n plus m by 2 n plus m by 2 plus 1 plus half, that will be plus 1, right? So this will be plus 1 log n by 2 or n plus m by 2 minus n. So this is n plus m by 2, this will be plus because there is minus, and then minus half log 2 pi. Similarly here this will be n minus m plus 1 2 log of n minus m by 2 plus minus n minus m by 2 minus half log 2 pi. So 1 log 2 pi, 1 log 2 pi cancels out, and you can, here it will be m, right? Because n by 2 and there minus n by 2 cancels out. So this will, sorry, this will be also be plus. So mine m and m here it will cancel out, so there will be n. So you can write it as, simplifying is, it will be n plus half log n minus n plus m plus 1 by 2 log, if you take n by 2 common, this will be 1 plus m by n, so that we can use the approximation, minus n minus m plus 1 by 2 log n by 2 1 minus m by n minus half log 2 pi and by plus n and plus n. Or did I do something? No, 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 no. This is cancels out, so there will be a log 2. Okay, so for this now we will use okay, so one thing I missed out, so there will be this term. For this we will do, for this it will be will do log 2 log 2 minus n. Okay, there will be minus n log 2. So this and this cancels out again. So it's a tedious calculation, so we need to, so now we will use some approximation. Now approximations, so since m is very less than n, we can use following expansion. That log into 1 plus minus m by n is equal to log 1 plus x is plus minus x m by n minus m square by 2n square plus the order of m cube by n cube. Okay, so we will use these first two terms only. So if you use the first two terms, then the equation becomes, so first for this it will be m by n. Okay, so log of, so w m n, that will become n plus half log n minus half log 2 pi minus n log 2. Now first 1 plus m by n will be using this, so then minus half n plus m plus 1 n plus m plus 1 into, so this will be, so this will be for log of this to this, so log n because here this is log n minus log 2. Now for log of, then log of, sorry, log of this is done, log of 1 plus m by n, so this will be plus m by n minus m square by 2n square Similarly here this will be minus half n plus n minus m plus 1 log n minus log 2, but the only difference it will be for minus, this is minus, so this is minus m by n minus m square by 2n square. Okay. Okay. So now if you simplify it, then regarding log n, so only term that remains for log n, so here n, here n, so n cancels out, here minus plus m, here minus m, so m cancels out, so here there is plus half n, here minus half, there is minus half, so 1 minus half and minus half cancels out, so this term cancels out, only remains half minus half log n for this. So this one is minus half log n, and log 2 is there because there is, okay, so it's not better to keep it there, or it will not mean something else. So this will be n n. Now for log 2, similarly here there is minus n and there is plus n, so for log 2 it will be little difficult, right? For log 2, so let's say this log 2 plus log 2, what are those things? There is minus n, there is minus plus plus, so plus n plus m plus 1 by 2 plus n minus m plus 1 by 2. So this cancels out, so only remains 1. So this will be 1 log 2, and here minus half log pi will be there, minus half log 2 pi, and for m square by n square, so if for m by n, this will be okay. Now for m by n it will be plus m by n. For m by n you can see these are like quite similar, so that will cancels out, right? So this will be cancels out. Only thing remains is m square by 2n square, that is positive, and it becomes n plus m, plus 1 plus n minus m plus 1 divided by 2. Divided by 2, that means this cancels out, so this will be around then minus half log n plus log 2 minus half log 2 pi, and there is n square by 2, so you can get it around minus m square by n. So this is minus m square by n. So this is this one, and for m by n, sorry, for m by n it will be m by n, it will be n minus m plus 1 by 2, sorry, n minus m plus 1 by 2 minus n plus m plus 1 by 2. So if you take that, then this will be m square by 2n square around 2n plus 2 by 2 minus m, m square by 10 square 2 minus m by n into positive, this is 1 cancels out, and this becomes m square m by minus m by 2 into 2. Okay, so which happens to be this m square by 2n, and there is also minus m square by 2n, so it becomes minus half log n plus log 2 minus half log 2 pi minus m square by 2n square, m square by 2n, here also m square by 2n, here m square by n 2n, so minus minus plus, so this will be m square by n, so m square by n, so here m square by, so this term becomes minus m square by 2n, and this square by minus m square by 2n, so adding this become minus m square by n. So basically we got this. So now if we got this, so after simplifying, we get log of Wmn as half log n plus log 2 minus half log 2 pi minus m square by 2n, which brings to give you Wmn is equal to, so whatever the in the log there will be, so in there will be log, so 2 pi 2 by pi n, so this will be 2 by pi n to the power half into exponential of minus m square by 2n. So after doing all this, we got this distribution. So this is the final expression of the probability. So probability distribution function. Okay, so this was a laborious calculations. So we will resume our class from here in the next session.